Good afternoon, Year 9s. We're going to do a couple more examples now about this time how to use Pythagoras theorem when you in a real world situation. So if you're doing some problem solving. I have a look at this little part from your textbook. This is just giving you 5 steps to follow when you're trying to use Pythagoras theorem to solve real world problems. The first one is that we need to identify and draw right angled triangles. Secondly, we're going to label them. Thirdly, we're going to use Pythagoras theorem. Fourthly, we're going to solve the problem. And then the final step, which is often a very important step that people overlook, is that we're going to check that the answer you have appears to be reasonable in the given situation. So given the measurements that you've been given at the beginning of your question and so on. So the 3 steps in the middle we already have done. Okay, we know how to do those steps. So we're just going to practice doing the first step and the last step with these problems. Here's our first problem. All right, so we've got here 2 skyscrapers. They're located 25 meters apart, and there's a cable there which links the 2 buildings. Find the length of the cable if the buildings are 50 meters and 80 meters in height. Give your answer to 2 decimal places. Well, there's a beginning of a drawing here for us, okay, but I don't see any right angled triangles there. The question that we are trying to find out is how long is this cable here? So that's what we need to think of. And also, we now need to figure out where our right angled triangle is and find out what the measurements are. So the first thing I'm going to do is actually to draw a line across from there which is parallel to the ground. And I know how long that line is because they're going to be the same distance from the ground as it is, I beg your pardon, they're the same distance apart at the ground as they are halfway up in the air. So that's our first part of our triangle. I'll just redraw the triangle over here. Okay, so we've got 25 meters down the bottom. The second distance that we're going to need to find, I'm just going to call this C because C stands for cable, but it's also the letter that we're used to using for Pythagoras theorem as the hypotenuse. We now need to know what is that vertical distance there. And we've been told that one of the buildings is 50, and I'm going to guess that is the shorter building is 50, and the taller building is 80. Here's our other bit of information. So this distance here is going to be 80, subtract 50. So that distance there is going to be 30 meters. We now have a triangle with 3 sides, one of them unknown, and we can simply use Pythagoras theorem to solve that triangle. So I'll just redraw it down here. We've got 25, 30, and C. It's a little bit out of proportion, but we'll work with it. Okay, so we've got A squared plus B squared equals C squared. Which one is the hypotenuse? In this case, C, our unknown, is the hypotenuse because it's the longest side and it's also directly opposite the right angle. So I can substitute the other 2 numbers in there for A and B. So I've got 25 plus 30 squared, 25 squared plus 30 squared is C squared. Now it's simply a matter of getting out my calculator. I'll move that over so we can see a little bit better. So I've got 25 squared. Hang on, I've hit the wrong button. Move it back again. Okay, 25 squared, that one's squared, is 625 plus 30 squared is 900 equals C squared. Now we've got, add the 2 things together, 625 plus 900 is 1525 equals C squared. We now need to take the square root of both sides. And there's my square root button. And there's the answer, 39.05124. 39.05124 and so on is equal to square C. I'm just going to scroll up And it says, give the answer correct to 2 decimal places. So if I look at this 2 decimal places, I need to cut it off there. The next digit is a 1, so this gets rounded to 39.05 meters is equal to the distance of C. I'm just going to scroll back up here and look at the diagram and see, is 39 meters a reasonable length for that side? And I'm just going to check here. Remember that the hypotenuse has to be longer than both the sides, and 39 is longer than both 25 and 30. And it's also in the same ballpark. If I came up with a number there that said 7,000, I would know that it was the wrong answer. So I'm going to say agree and say that that is a reasonable answer for that first question there. All right, here's our second problem that we're going to go through together. This one's a little bit different because we're not given any diagram at all. So we have to draw our own diagram from scratch. We've got the question. It says 2 bushwalkers are standing on different mountain sides. According to their maps, one of them is at a height of 2120 meters and the other is at a height of 1650 meters. The horizontal distance between them is 950. Find the direct distance between the 2 bushwalkers. Give the answer correct to the nearest meter. Okay, so here I'm going to draw my 2 mountain sides. And it says that the first bushwalker is here at 2120 meters. So this distance here. Oh, beautiful straight lines I've got here. That distance there is 2120, whereas the other one is at a height of 1650. Okay. It says the horizontal distance between them is 950. So that's our horizontal distance. It's 950. But what we are asked to calculate is what is the direct distance between them. All right, so here's our right-angled triangle. And we're asked to find out what is this distance here, C. Got a lot of information there. We might just get it off our diagram and onto a triangle by itself and see what information we've got and what is missing. So there's our right-angled triangle. There's the 950 meters. There's the x. So what we need to calculate in order to work out this unknown side is what is this third side here? And we're given the 2 heights that they are. So we know that the 2 bushwalkers are at those 2 heights. So we can calculate the vertical distance between them is 470. Okay, so this one here is 470 meters. All right, we are all set now to put into action our Pythagoras theorem. Here we go. A squared plus b squared equals c squared. In this case, the hypotenuse is again our unknown, and the 2 other sides, the 2 perpendicular sides, are the 2 sides that we've been given. So here we go. We can just plug all of this into our calculator, and I'm going to do all of it at once. So we've got 470 squared plus 950 squared equals 1,123,400. It's equal to x squared. All right, so now we need to take our square root of both sides. Here's my square root button, and I'm come up with 1059.9056 and a few more. Okay, so we've done our calculations. We now need to go back to our question and just reread it. It says, give your answer correct to the nearest meter. So the nearest meter means I'm going to round it off to no decimal places. If we have a look here, this number 9 means that this next digit needs to go up. So we're at 59. It's actually going to go up to 60 is our distance there. Okay. So there we've got, oh, didn't work. 10 centimeters. It's playing up on me. There we go. So that's our final measurement there. Well, let's go back and see if that is a reasonable measurement. 1060 is a reasonable measurement for our triangle here, which is 950 and 470. It is. It's in the same, it's about the same size. It's not an order of magnitude bigger, but it is bigger than both the hypotenuse and, I beg your pardon, it is the hypotenuse, so it is longer than both the